Antidepresi. Depresi merupakan suatu kondisi yang ditandai rasa sedih terus menerus, hilang konsentrasi, pesimis, khawatir, dan hilang rasa senang. Komplikasi depresi, bunuh diri salah satunya. Penyebabnya dikaitkan karena kurangnya neurotransmitter eksitatori monoamin, yaitu norepinefrin, serotonin, dan dopamin. Golongan antidepresi. 1. Inhibitor pengambilan kembali norepinefrin dan serotonin. 2. Inhibitor selektif pengambilan kembali. 3. Inhibitor selektif pengambilan kembali serotonin. 4. Antidepresi atipikal. Dan yang kelima, inhibitor monoamin oksidase. Penggunaan obat depresi dapat dilakukan selama berbulan-bulan sampai dengan bertahun-tahun. Inhibitor pengambilan kembali norepinefrin dan serotonin. Mekanisme kerja: menghambat penguraian norepinefrin sekaligus serotonin. Karakteristik: absorpsi berlangsung cepat karena berikatan dengan protein plasma. Metabolisme dengan cara hidroksilasi dan glukuronidasi. Efek samping dan toksisitas. Efek sampingnya berupa kejang, sedasi, hipotensi, efek antikolinergik, gangguan jantung, peningkatan berat badan. Toksisitas berupa agitasi, bingung, dan penurunan daya ingat. Inhibitor pengambilan kembali serotonin selektif. Mekanisme kerjanya: menghambat penguraian serotonin secara selektif. Karakteristik: pilihan utama dalam pengobatan depresi karena memiliki efek samping yang lebih kecil dibanding golongan lain. Aman bagi anak-anak dan manula. Efek samping dan toksisitas. Efek sampingnya berupa gangguan fungsi seksual dan gangguan saluran cerna. Toksisitasnya yaitu sindrom serotonin dengan gejala kecemasan, agitasi, bingung, peningkatan tekanan darah, dan takikardia. Inhibitor monoamin oksidase. Mekanisme kerjanya menghambat enzim monoamin oksidase yang menguraikan senyawa-senyawa monoamin. Karakteristik: efek antidepresan inhibitor MAOA lebih kuat dibanding dengan inhibitor monoamin oksidase B. Dapat menyebabkan hipertensi krisis bagi pengguna jika dikonsumsi bersamaan dengan makanan fermentasi atau yang diawetkan dan obat simpatomimetik. Efek sampingnya berupa gangguan fungsi hati, gangguan saluran cerna, hipotensi ortostatik, dan peningkatan berat badan. Antidepresan atipikal. Mekanisme kerjanya bekerja menyerupai atau analog serotonin. Karakteristik: bupropion tidak boleh digunakan pada penyakit kejang dan gangguan pola makan. Nefazodon dapat menyebabkan kegagalan fungsi hati. Efek samping: gangguan fungsi seksual, gangguan saluran cerna, hipotensi ortostatik, peningkatan berat badan, dan efek Berikut gambar obat-obat antidepresi. Untuk lebih jelasnya, mari kita saksikan tayangan video berikut ini.
In this lecture, I'm going to talk about antidepressants, so let's get right into it. We all experience changes in mood. Sometimes we feel happy and energetic, and other times we feel sad and irritable. Fortunately, these moods usually don't last long, and we can go about our normal daily routine. However, life is not always that simple, because there are times when we might experience unusually long periods of sadness, guilt, and decreased interest in activities. This is what we call depression. Sometimes depression can occur alone, and other times it is a part of a larger disorder such as bipolar disorder. People with bipolar disorder experience periods of depression alternating with periods of mania, in which a person feels abnormally optimistic, euphoric, and energetic. Now, treatment of depression and bipolar disorder often involves use of antidepressant drugs, which work by elevating levels of certain neurotransmitters in the brain. This led to development of monoamine hypothesis, which states that depression results from deficiency in one or more of the three key monoamines, namely serotonin, norepinephrine, and dopamine. Another hypothesis states that this monoamine depletion could also cause the postsynaptic receptors to upregulate, thus leading to depression. Lastly, the monoamine hypothesis of gene expression suggests that there might be an abnormally functioning gene that is responsible for causing depression. Now, all that being said, keep in mind that these hypotheses are overly simplistic and they don't accurately explain everything that we observed in research studies. However, they do give us partial explanation as to why antidepressants work. So now, let's switch gears and let's talk about antidepressant drugs. Based on their mechanism of action, antidepressants can be divided into 5 different classes. Number 1, selective serotonin reuptake inhibitors, SSRIs for short. Number 2, serotonin norepinephrine reuptake inhibitors, SNRIs for short. Number 3, tricyclic antidepressants, TCAs for short. Number 4, monoamine oxidase inhibitors, MAOIs for short. And lastly, number 5, atypical antidepressants. So now, before we start discussing each class, let me draw some neurons that will help us understand how these antidepressants differ in the way they work. So here we have presynaptic serotonergic neuron, or in other words, serotonin-producing neuron. And next to it, I'm gonna draw presynaptic noradrenergic neuron, or in other words, norepinephrine-producing neuron. Now, these two neurons interact with their postsynaptic counterparts. So, as you may have already guessed, postsynaptic receptors of noradrenergic neuron are beta and alpha-1, while postsynaptic receptors of serotonergic neuron are serotonin, often abbreviated as 5-HT receptors. Now, keep in mind that there's quite a few subtypes of serotonin receptors, but for now, let's just keep it simple. So going back to our two neurons, the serotonin is synthesized from an amino acid tryptophan by serotonergic neurons, and it is there stored in vesicles awaiting regulated release. On the other side, norepinephrine is synthesized from an amino acid tyrosine by noradrenergic neurons, and it is also stored there in vesicles awaiting release. So now, what exactly happens when these neurotransmitters are released? Well, there are a few key things to remember. When serotonin and norepinephrine get released, they begin to stimulate the receptors, and at the same time, they are transported from the synapse back to their neurons in a process called reuptake. Now, serotonin is reabsorbed by serotonin transporter, abbreviated as SERT, while norepinephrine is reabsorbed by norepinephrine transporter, abbreviated as NET. Another important thing to remember is that once the serotonin and norepinephrine get reabsorbed back to their neurons, they're partially repackaged into synaptic vesicles and partially broken down into inactive metabolites by an enzyme monoamine oxidase, abbreviated MAO. Now let's move on to discussing antidepressant drugs, and let's start with selective serotonin reuptake inhibitors. So as you can tell from their name, SSRIs inhibit reuptake of serotonin, and they accomplish that by blocking serotonin transporter. This results in increased levels of serotonin available to bind to postsynaptic receptors. Examples of SSRIs include citalopram, escitalopram, fluoxetine, fluvoxamine, paroxetine, and sertraline. Now, besides being used for depression, SSRIs are also used for other psychiatric disorders, such as generalized anxiety, post-traumatic stress disorder, and obsessive-compulsive disorder. Okay, so this whole mechanism of action looks pretty straightforward. But then you may wonder, why these antidepressants take weeks to produce maximum benefit? Well, a new research gives us a little insight into why this happens. So recently, scientists discovered that in people with depression, G proteins tend to cluster in the patches of brain cell membranes rich in cholesterol called lipid rafts. Now, when stuck on these rafts, G proteins lack access to a molecule called cyclic AMP, which is necessary to work and transmit signals of serotonin. However, later on it was discovered that SSRIs also tend to build up in these lipid rafts, which resulted in the gradual movement of G proteins out of the rafts toward regions of membrane where they are able to function better. So here we have a possible reason why antidepressants take so long to produce maximum benefit. Now, when it comes to side effects, excessive stimulation of serotonin receptors in the brain may lead to insomnia, increased anxiety, and irritability. Next, excessive stimulation of spinal serotonin receptors may lead to sexual side effects, including erectile dysfunction, and stimulation of serotonin receptors in the gastrointestinal tract, as well as in the CNS, may lead to nausea, vomiting, and diarrhea. Lastly, abrupt withdrawal of an SSRI can result in temporary deficiency of synaptic serotonin, which in turn may lead to unpleasant symptoms such as headache, nausea, vomiting, agitation, and sleep disturbances. Now, let's move on to serotonin norepinephrine reuptake inhibitors. So, SNRIs, just like SSRIs, work by inhibiting reuptake of serotonin via inhibition of serotonin transporter. But what makes them different is their ability to additionally inhibit norepinephrine transporter. This results in increased levels of both serotonin and norepinephrine, which can then bind to the postsynaptic receptors. Examples of SNRIs include venlafaxine, desvenlafaxine, duloxetine, and levomilnacipran. Now, similarly to SSRIs, SNRIs are also used for depression, anxiety, and panic disorders. However, unlike SSRIs, SNRIs have been shown to be also effective in reducing pain associated with fibromyalgia, as well as other pain caused by neuropathy. This unique pharmacological action of SNRIs is thought to be related to enhanced noradrenergic activity within the central nervous system. Now, when it comes to side effects, they are very similar to those of SSRIs. However, because of additional noradrenergic activity, SNRIs may increase blood pressure and heart rate. Now, let's move on to tricyclic antidepressants. So, this class of antidepressants was named after their core chemical structure, which contains 3 rings connected together. Unlike the other classes of antidepressants, TCA's mechanism of action is not as straightforward. So, just like SNRIs, TCAs were found to primarily inhibit reuptake of both serotonin and norepinephrine by blocking both of their transporters. However, different tricyclic agents do this with different level of selectivity. In other words, some TCAs, such as desipramine, are more selective inhibitors of norepinephrine transporter than serotonin transporter. Furthermore, TCAs also block many other receptors, such as alpha receptors, histamine receptors, and muscarinic receptors. However, blockade of these other receptors is thought to be responsible for their side effects more than their antidepressant activity. Examples of TCAs include amitriptyline, moxepine, clomipramine, desipramine, doxepine, imipramine, meprotylene, nortriptyline, and protriptyline. Now, TCAs are mainly used for depression. However, due to their broad mechanism of action, they also prove to be beneficial in treatment of other medical problems. For example, amitriptyline and nortriptyline have been used for migraine prevention as well as treatment of neuropathic pain. On the other hand, TCAs such as doxepine have been used for insomnia. Now, when it comes to side effects, inhibition of alpha receptors leads to orthostatic hypotension and dizziness. Inhibition of histamine receptors leads to sedation, and inhibition of muscarinic receptors leads to anticholinergic effects, such as blurred vision, dry mouth, constipation, and urinary retention. Lastly, TCAs block cardiac sodium channels and produce effects similar to antiarrhythmic agents such as quinidine. This ultimately can lead to cardiac conduction abnormalities. Now, let's move on to monoamine oxidase inhibitors. So, monoamine oxidase is a mitochondrial enzyme that degrades monoamines such as serotonin and norepinephrine. MAO exists in two subtypes, A and B, which are differently distributed in tissues such as brain, gut, and liver. Now, MAO subtype A preferentially metabolizes serotonin, but will also metabolize norepinephrine and dopamine, while MAO subtype B preferentially metabolizes dopamine. This is why the inhibition of MAO subtype A is thought to be responsible for antidepressant effects of majority of MAOIs. So the primary mechanism of action is pretty straightforward. MAOIs inhibit the activity of MAO enzymes, preventing breakdown of monoamine neurotransmitters, ultimately increasing their availability. Now, examples of MAOIs include isocarboxazid, phenelzine, and trinylcypromine, which are all irreversible inhibitors of both MAO subtype A and MAO subtype B, which in turn makes them effective for treatment of depression. Another example of MAOI, which is a bit different from the rest, is selegiline, which is a selective inhibitor of MAO subtype B, and therefore has been shown to be effective in reducing symptoms of Parkinson's disease, which results from depletion of dopamine. So now, on the surface, it seems like MAOIs could be a good choice for the first or the second line antidepressant. However, in practice, they are usually a very last choice. And the reason is that MAOIs show not only high incidence of drug-drug interactions, but also drug-food interactions. As I mentioned earlier, MAO enzymes are present in the gut. There, they play an important role in breakdown of monoamines ingested in food. The problem arises when inhibited MAO enzymes can't metabolize tyramine, which is contained in foods that have been aged or fermented. Now, built-up tyramine is taken up into the synaptic nerve terminals, where it acts as a catecholamine-releasing agent. The release of large amount of catecholamines caused by tyramine leads to hypertensive crisis and potentially a stroke. This is why patients that are prescribed MAOIs due to lack of other options must be educated about avoiding tyramine-rich foods. Okay, so now finally we can move on to atypical antidepressants. This class includes agents that have actions at several different sites and thus don't exactly fit into the other classes. Examples of atypical antidepressants include bupropion, mirtazapine, trazodone, efazodone, vilazodone, and vortioxetine. Now, each of these drugs has a little different mechanism of action. So, bupropion is a weak norepinephrine and dopamine reuptake inhibitor. Besides being used for depression, bupropion was found to be effective in reducing nicotine cravings and withdrawal symptoms. Next, mirtazapine is an alpha-2 receptor antagonist. So by blocking presynaptic alpha-2 receptors, mirtazapine increases noradrenergic and serotonergic neurotransmission. Additionally, mirtazapine is thought to have some postsynaptic serotonin receptor blocking activity, as well as antihistaminic activity, which explains its sedating effects. Next, we have trazodone and efazodone. Their therapeutic effect is thought to be related to their ability to inhibit reuptake of serotonin, as well as block postsynaptic serotonin receptors of subtype 2A, which are the bad serotonin receptors. Activation of these serotonin 2A receptors is thought to contribute to depression. Additionally, both of these agents antagonize histaminic H1 and adrenergic alpha-1 receptors, which may account for their sedative effects. Next, we have vilazodone. which has similar sounding name to trazodone and nefazodone, but again it has its own unique mechanism of action. So vilazodone is a serotonin partial agonist reuptake inhibitor, meaning it partially stimulates serotonin receptors and it inhibits reuptake of serotonin. Finally, we have vortioxetine, which has a mechanism of action that is still a little unclear, but it is believed to be related to its ability to inhibit serotonin reuptake, as well as activate and block different subtypes of serotonin receptors involved in mood regulation. And now, before we end, I just wanted to briefly discuss lithium, which is a mood stabilizing drug in its own class. Lithium has been used in medicine for a very long time, initially for depression, but currently for bipolar disorders. Unfortunately, lithium has a fairly narrow therapeutic index, which means that minor changes in dose or its blood levels can lead to toxicity. Now, despite years of research, the exact mechanism of action of lithium as a mood stabilizer is still not entirely known. However, few mechanisms of action have been proposed. One in particular that has been extensively studied states that lithium inhibits the recycling of neuronal membrane inositol lipids. Okay, so this may get a little complicated, but bear with me. So, in the inositol lipid pathway, G-protein coupled receptors such as serotonin receptors activate phospholipase C, PLC for short, which cleaves phosphatidylinositol 4,5-bisphosphate, PIP2 for short, to the signaling molecules diacylglycerol, DAG for short, and inositol 1,4,5-trisphosphate, IP3 for short. Next, IP3's action is terminated by conversion to inositol 4,5-bisphosphate, IP2 for short. And at this point, the enzyme inositol phosphatase comes around and dephosphorylates IP2 to inositol phosphate, IP1 for short. And lastly, another inositol phosphatase dephosphorylates IP1 to free inositol, which is necessary for the regeneration of PIP2. So now, what lithium does is it inhibits both inositol phosphatase enzymes, and thus decreases cellular responses to neurotransmitters that are linked to the second messenger system. Now, lithium also was found to inhibit glycogen synthase kinase 3, GSK3 for short, mimicking the Wnt protein signaling pathway. So basically, we have these Wnt proteins, which are secreted glycoproteins acting as a signaling molecules. When they bind to receptors of the so-called frizzled family, they induce certain reactions which ultimately result in inhibition of GSK3. Now, GSK3 regulates critical processes such as axon remodeling, synapse formation, plasticity, and neurogenesis. What the research has found, though, is that the abnormal activation of GSK3 seems to be associated with several neurological and psychiatric disorders, such as bipolar disorder. So, because lithium inhibits GSK3 directly and non-directly, it's likely that this particular mechanism contributes to its therapeutic effect. Unfortunately, this doesn't end here. Lithium brings about changes in all of the major neurotransmitter systems in the brain. And I think at this point you had enough, so we're not gonna dig further. And with that, I wanted to thank you for watching. I hope you enjoyed this video, and as always, stay tuned for more.